It's incredible to think about the changes that cable technology has undergone since the first copper cables were laid. Now, telecommunications cables, unseen and mostly unremarked upon, provide the web that binds our interconnected world together.
Since the 1980s, copper cables have been replaced by fibre optics, carrying data as light rather than electricity. Today, these cables carry 95% of global communication, much of which travels through Madley Earth Station.
From this transmission room, telephone, fax, internet and TV signals are sent down cables underground to either the BT Tower or to the coast, where the cables disappear under the sea to almost everywhere in the world.
And to make sure the signal definitely arrives, they send it by 2 different routes to the same destination.
This is what a fibre optic cable looks like. It's covered in this sort of durable polyurethane, which not only protects it, but is an excellent insulator. And inside, this is the optic fibre. Now, that's only 8 microns across, so that's thinner than a human hair, but it's tougher than steel.
A fibre optic cable has a core of ultra-fine glass threads coated in a reflective material. An electric signal is converted into pulses of light billions of times a second and transmitted by a laser beam. Within the light are digitised videos, voices and computer signals. The outer walls act like mirrors reflecting the light onwards to its destination, where the digital information is converted back into electrical signals.
So is this your actual fibre optic cable then?
Yes, it is, yes. You can fit on, for example, this cable here, up to 500,000 telephone calls onto a single fibre.
My goodness, I mean, how does that compare with something like satellite technology?
It's a much greter bandwidth. Newer technology will also increase that. Some equipment here, we're looking at tens of millions of telephone calls per second on an optical fibre.
Down one single wire?
On a single fibre, yeah, it's very impressive.
That sounds pretty revolutionary,
It's pretty good, yeah. When you think we've gone from 100-odd years ago, from a single copper cable encased in thick rubber, going through to coaxial cables carrying analog signals, to the latest fibres carrying digital, it's amazing how things have progressed.
This particular wire, where does this go?
This is connected to our backhaul equipment, so there'll be a switch somewhere on site, which will then connect it to the rest of the national network.
Zooms out.
Zooms out to eventually wherever it is in the world, India, Europe, America, anywhere.
It's like one of those giant telephone exchanges, just plugging wires all over, isn't it?
It's an invisible network.
All at the speed of light.
Very, very fast indeed.